Welcome. Cosine similarity. Cosine similarity tells us how similar two vectors are by looking at the angle between them. The basic formula is the dot product of the two vectors divided by the product of their magnitudes. So we can think of cosine similarity as a way of measuring whether two vectors point in a similar direction. Here we have two vectors. Vector A is 1, 2, 3 and vector B is 4, 5, 6. These are simply Python lists containing 3 components each. Geometrically, these vectors can be represented as directions in 3-dimensional space. The important thing to notice is the angle between them. Cosine similarity measures this angle. When two vectors point in almost the same direction, their cosine similarity will be close to 1. Now let's look inside the dot function. First, the function checks that both vectors have the same number of elements. Then it initializes total to 0. Next, we loop through the vectors and multiply matching components. For the first position, we calculate 1 times 4 giving 4. For the second position, 2 times 5 gives 10. And for the third position, 3 times 6 gives 18. We add these values together. 4 plus 10 plus 18 gives us 32. So the dot product of A and B is 32. In simple terms, the dot product multiplies matching components and then adds all those products together. The magnitude. Next, we calculate the magnitude of each vector. The magnitude represents the length of a vector. Notice something important in the code. The magnitude function does not implement a completely new calculation. Instead, it reuses our dot product function. For vector A, we calculate dot A of A. That gives us 1 times 1 plus 2 times 2 plus 3 times 3. The result is 14. Then we take the square root of 14, giving approximately 3.742. For vector B, we calculate its dot product with itself. That gives us 16 plus 25 plus 36, which equals 77. The square root of 77 is approximately 8.775. So the magnitude of A is 3.742 and the magnitude of B is 8.775. Combining everything, now we have all the pieces we need. The dot product is 32. The magnitude of A is 3.742 and the magnitude of B is 8.775. The function also checks whether either magnitude is 0. This is important because we cannot divide by 0. Since both vectors are non-zero, we continue with the calculation. We divide 32 by 3.742 multiplied by 8.775. This gives approximately 0.975. The function then rounds the result to 3 decimal places, so our final cosine similarity is 0.975. And because this value is very close to 1, the two vectors point in very similar direction. In fact, an angle whose cosine is 0.975 is approximately 12.8 degrees. So the number 0.975 has a geometric meaning. It tells us that the angle between these two vectors is quite small. The full data flow. Let's put the entire process together. We start with our two vectors A and B. From them we calculate the dot product, which is 32. At the same time we calculate the magnitude of each vector. The magnitude of A is 3.742 and the magnitude of B is 8.775. Finally, we divide the dot product by the product of the two magnitudes, and that gives us 0.975. Notice that the same dot function is reused 3 times. Once to calculate a dot b, once to calculate a dot a, and once to calculate b dot b. So from start to finish, cosine similarity is really measuring one simple geometric idea. How closely are these two vectors pointing in the same direction? A cosine similarity close to 1 means the vectors point in nearly the same direction. So remember, same direction means high cosine similarity.